So in question number 18, spectral lines in Lyman series of emission spectra of atomic hydrogen are resolved by spectrometer of resolving power lambda upon d lambda equal to x. If the principal quantum number of the highest energy level for which line in Lyman series can be resolved clearly is n, where n is very greater than 1, then n depends on x as n raised to the power p equal to x, then we have to calculate the value of p. So from the formula of the spectral lines, I can say that 1 upon lambda is equal to Rydberg constant into z square. Since the series is Lyman, so it is 1 divided by 1 square minus 1 divided by n square. So if I differentiate this equation, then minus d lambda upon lambda square is equal to rz square into 2 divided by n cube. So if I calculate the value of d lambda by lambda, so it comes out to be 2 times rz square divided by n cube into lambda. So if I substitute the value of lambda from this equation, since n is very greater than 1, so I can write lambda is equal to 1 upon rz square. So if I substitute this 1 divided by rz square, so this comes out to be 2 by n cube. Now in the question it is given that lambda upon d lambda is x, so it is equal to 1 by x. So from this equation I get the value of x, which comes out to be n cube by 2. So x is proportional to n raised to the power 3. So on comparing, the value of p comes out to be 3. So the correct answer for question number 18 is 3. Let's move to question number 19. In question number 19, a parallel beam of light having intensity I0, area of cross section A, falls on a metallic plate at an angle theta equal to 60 degree with normal to surface. If half of the light is reflected and half of the light is absorbed, it exerts force on metallic plate equal to I0 A by C under root x by y, where x and y are co-prime. Then we have to calculate the value of x plus y. So let's analyze the situation. Suppose this is a metallic surface and the beam is incident on the metallic surface in this fashion, and this makes an angle of 60 degree with the normal. Suppose n photons are coming in this beam, then energy per unit time passing through this cross section in time delta t can be written as delta E by delta t, that is equal to n times Sc by lambda, that is the total energy of photon beam, divided by delta t. So if I divide by the area, that is A, then it is equal to I0. So we get the value of NH upon lambda into delta t. So it is equal to I0 A by C. Now let the total momentum of this beam when it passes through a cross section can be written as n into h by lambda. So I can write the initial momentum as P initial is equal to n into h by lambda. If this angle is 60 degree, then this angle is also 60 degree. So I can write into cos 60 degree minus j cap plus sin 60 degree into I cap. I have considered this as my positive x-axis and this as my positive y-axis. So once they get reflected, then it reflects at an angle of 60 degree. So now I can write final momentum, but it is given in the question that half of the light is reflected and half of the light is absorbed. It means n by 2 photons are absorbed and n by 2 photons are get reflected. So if I write the final momentum, I can write n by 2 into h by lambda into cos 60 degree j cap plus sine 60 degree into I cap. So if I find out the change in momentum delta P, so that is equal to P final minus P initial. So it comes out to be NH by lambda into root 3 by 4 minus I cap plus 3 by 4 into J cap. So if I calculate the magnitude of delta P, it comes out to be NH by lambda into root 3 by 4. So now we know that F is equal to delta P by delta T. So it is equal to under root 3 by 4 into NH by lambda into delta T, and the value of NH by lambda into delta T is I naught A by C. So it is equal to 3 by 4 into I naught A by C. So on comparison, the value of X is 3 and the value of Y is 4. So their summation X plus Y is 7. So the correct answer for question number 19 is 7. Let's move to question number 20. In question number 20, an object of height 2 cm is placed at some distance from a lens. A sharp image of height 6 cm is formed on the screen. It means the magnification is 3 times. Now the object is moved away from lens by a distance of 4 cm. A sharp image is again formed on the screen after adjusting the screen lens distance, and this time height of image is 4 cm. It means that the magnification in this case is 2. Find the focal length of the lens in centimeter. So suppose this is the focal length and this is the position of the object. Initially it is a distance x. Then if the focal length is f, I can write, if I apply the lens formula, 1 upon v minus 1 upon u is equal to 1 upon f. So in the first case, magnification is 3 times. So I can write 1 by 3x, 1 divided by minus x. So it is 1 by x is equal to 1 by f. So from here, the value of f comes out to be 3x by 4. In the second case, the object is moved in this direction by a distance 4. So now u will be minus of x plus 4. And the magnification in this case is, so it is equal to 2 times x plus 4. So again if I apply the lens formula, so 1 divided by 2 times x plus 4 plus 1 divided by x plus 4, it is equal to 1 by m. So on solving equation 1 and 2, we get the value of x, and the value of x is 32 centimeter. So the value of f is equal to 3 by 4 of 32. So it is equal to 24. So in the question it is asked the focal length of lens in centimeter is 4n. So if I equate this is equal to 4n, then the value of n comes out to be 6. So the correct answer for question number 20 is 6. So by this, I wish you all the best for your preparation. Have a good luck. Thank you.